It's mixed on the beat.
So first, we're gonna show you all the trigonometric functions for the piece of bread. It was very simple to get all this information since we already had the sides that would measure them. So we obviously used SOHCAHTOA, which means opposite over hypotenuse, which is 6 over 11. For cosine, we're gonna use adjacent over hypotenuse, which is 10 over 11. And for tangent, we're gonna use opposite over adjacent. And here we also have the inverses of each one. Here we can see an illustration of the bread, which we already clearly know that there's a 90-degree angle, so therefore it was very easy to get all the angles. So to find angle A, we first used sine of A, which is equal to 6 over 11, and sent the sine of A to the other side as an alternative notation and multiply that times 6 over 11, and the answer was given of angle A of 33.1 degrees. And for B, angle B, it's exactly the same but with cosine. We send it to the other side as an alternative notation and multiply that times 6 over 11, and the answer will be given of angle B of 56.9 degrees. And for angle C, we already know that it's a 90 degree because it's a right angle represented right here.
This is Mixlot Production.
We're gonna show you the trigonometric functions for the image we showed you previously. For sine, the trigonometric function, which is opposite over hypotenuse, is 3 over 4 because first it was 18 over 24, but it was simplified. Cosine 5 over 6, again it was simplified. Tangent 9 over 10, simplified, and the inverse functions is basically the same but reciprocal. And as we can see here, the triangle, this is how. Like Roberto, I use sine of A, which in this case is 3/4, then send sine to the other side as an alternative notation multiplying 3/4. The answer gave me 48.6, and repeated the same process but with cosine of B, and the answer was 41.4, and angle C is 90.
Here we have a visual representation of a triangle we measured with all its sides. And first you need to get the trigonometric functions of it using SOHCAHTOA. So first we have sin with its reciprocal, cos with its reciprocal, and tan with its reciprocal. Now we need to get the three angles of the triangle, and by doing that we do sin of A and do its alternative notation and plug in that in the calculator, and it will give you the angle. And since we already know that angle C is equal to 90 and angle A is equal to 44.3, and that all angles have to add to 180, it's really simple to get the third angle by just doing a simple subtraction.
So to solve this triangle, it's actually fairly simple. The first thing that we need to do is get side C, because the information that we have is side A, side B, and angle of C. So with that information, we only have to do Pythagorean theorem, which is a squared plus b squared equals c squared. And with that information, we're gonna plug it in all the values, and in there we're gonna get c equals to 268.57 centimeters. And then we're gonna find all the trigonometric functions of the triangle using SOHCAHTOA of sine, cosine, and tangent, S, C, and T, which means opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Here we can get all the values in here by replacing them. And then for the angles, we're going to use sine of A, which is equals to 177 over 268.57, and it's going to give us of 41.22, and that's angle A. And then it's the same for B, but with cosine. And with that, we're going to get 48.77 as angle B. And we already knew that angle C was 90 degrees, because in the triangle we can see that it's 90 degrees in here, and because it's a right triangle.
For this triangle we were given two sides, one of them which was my height, which is 173 centimeters, and the second one which is the length of my shadow, which is 205 centimeters. To get the distance between the tip of the shadow and my head, we used the Pythagorean theorem. And our answer was 268.24 centimeters. After getting the three sides, we use SOHCAHTOA to find all the trigonometric functions, as we can see right here. And last, to find the angles, we used sine of A. We used the sine of A, send sine as sine -1 to the other side, multiplied, and it gave us 40.16, which we rounded to 40. And then we just added 40 plus 90, which is the other angle that was given, since it's a right triangle. 90 plus 40 equals 130. That we subtracted it from 180, and the answer it gave us is 50. Therefore, the other angle, or angle B, is 50, as we can see right here.
Here we have a visual representation of our triangle that we got with all the measures. Now first you need to get the trigonometric functions with SOHCAHTOA. So here we have sin with its reciprocal, cos with its reciprocal, and tan with its reciprocal. Now to get the three angles of our triangle, you're going to need to do sin A and then do the alternative notation with its C sin -1, and plug that on the calculator and it will give you this number. And since we already know that angle C is equal to 90 and angle A is equal to 29.3, and that all three angles have to be equal to 180, it's really simple to get the third angle. In conclusion, I really like this project because it gives you an idea of how many triangles are in your surroundings and how can you apply the rules we learned on the classroom on the real life, and how the architects that make all the buildings and houses use many shapes that you learned in classroom to make the buildings more stable.
I really enjoyed this project because after taking the picture of my right triangle, I noticed that there's a lot of triangles in our surroundings, because they're really important for like engineering and architecture and stuff like that, and also because I don't know, they're a primary shape, so they're really important. And the shadow part was really cool because it made us teens leave the house and go outside.
During this project, I learned a lot about the right triangles and angles themselves, and how many right triangles there actually are in the world around us. It was a very fun project, and I would totally do it again with my teammates. And yeah, it was very fun.
Fasten your seatbelts.
I really enjoyed this project. I really I really enjoyed this project. really enjoyed this project. I really enjoyed this project. I really enjoyed this. Yeah. I really enjoyed this project. I really enjoyed this project because after taking the picture of I really enjoyed this project. I really enjoyed this project. I really enjoyed this project. I really enjoyed I really I really enjoyed this project because after taking the picture of my right triangle, I noticed that there's a lot of triangles and right triangles in our surroundings because I don't know, I just noticed it. Es que así la... I really enjoyed this project because after taking the picture of my triangle, I noticed that there's a lot of triangles in our surroundings because they're really important for like architecture and
No puedo creerlo.
I really enjoyed this project. I really enjoyed this project because after taking the picture of my right triangle, I